Okay, we're back and we're going to talk about triangles now. So I'm going to attempt to squeeze it in the bottom of my paper here for triangles. Again, I can give you the formula, but I really want you to think about why the formula works. And so I'm going to take another rectangle because we already know that if we have the base here and if we have the height, we already know that this purple paper is, the area is base times height. And I can take any rectangle and turn it into triangles in some obvious ways. One way I could do it is by sort of slicing the rectangle in half from corner to corner. So if you do that, the height, which is here or here, and the base, the triangle would be exactly half of the rectangle. And so that's going to kind of lead us into the formula for the area of a triangle. It's always going to be half of the rectangle that surrounds it. And that's really obvious. I should have made a second one, but that's really obvious if we break it into right triangles, right? The height is here, the base is here, and the area of this triangle is 1/2 of the purple, right? But you can also break the triangle up in different ways, or the rectangle, right? I could go up to a point at the top and then back down. And if we break it up this way, the green triangle is also half of the purple rectangle. And that's because if I snip off the extra pieces and really turn it into a triangle, boy, these scissors are awful. Okay. Okay. So this triangle is exactly half of the rectangle because I can flip these and they fall, well, you actually have to flip them like this. They fall perfectly on top. So we've essentially created two congruent triangles out of that rectangle. So unlike a parallelogram where the areas are the same, a triangle, the area is exactly half of the rectangle that it was made from. And so the area formula for a triangle, and this goes for a right triangle or any other triangle. Okay, we have the base and the height. Just like in a parallelogram, the height is always the perpendicular distance between the base to the other vertices. So this is the height in a right triangle. And in a triangle like this, the height is there. I'm going to put a little h. And sometimes you might even see it written off to the side, height. So the area formula is 1/2 base times height, or you might see it written as base times height divided by 2, and those are exactly the same. So let's do just one quick example. Here's a triangle. The bottom length here is 2 times x plus 4 units long. And off to the side, this is 5 units. And the area of this triangle is 70 units squared. And I'd like you to solve for x. This is definitely more challenging than the other examples, but I still would like you to try it on your own. So pause the video if you're able and give this a try. Okay, so we always use the same process. Write down your formula. So the area of a triangle, I'm going to use 1/2 base times height, or half of the rectangle that it would be inside of. And I know a lot of information here. I know big A, it's 70. I also have an expression I can use for the base, and I have a number I can use for the height. So I'm going to go ahead and fill all that out. Area, whoops, I meant to write 70 equals, because big A is 70, 1/2 times the base times the height, which is 5. And so now I just have to think kind of carefully about how I'm going to solve this. Remember that with multiplication, order doesn't matter, but this plus in here is going to really cause me trouble if I'm not careful. So I'm actually going to rewrite this, and I'm going to reorder the multiplication. So I'm going to do 70 equals 1/2 times 5 times 2x plus 4. And the reason I'm doing that is because these I can multiply together really easily. 1/2 times 5 is just 2.5. So I've got 70 equals, this becomes 2.5 times 2x plus 4. And from here, I have two options for solving. I can divide both sides by 2.5 and get rid of that. Or what y'all are probably a little more comfortable with, I can distribute that 2.5. So I'm going to do that. So I've got 70 equals 2.5 times 2 is 5, so 5x, and 2.5 times 4, I hope I'm doing this right quickly in my head, is 10. So now all of a sudden we have a much easier equation to work with. So I'm going to go ahead and finish, subtract 10 from both sides. 60 equals 5x. And then I'm going to divide on both sides by 5. X equals 12. And I can verify that works by plugging it back in. If x is 12, then 2 times 12 is 24. 24 plus 4 is 28. And I could figure out that 1/2 times 28 times 5 gives me 70. And if it doesn't, then I know I've made a mistake. So that's it for this first lesson. There's going to be another question or two for you to answer, and then you can move on to the next assignment.